Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 class. Today we are going to wrap up systems of linear equations and linear inequalities. We have already talked about systems of linear equations. We know we can solve those by either graphing the system and finding the point where both lines intersect. We can use substitution method and substitute one variable in terms of the other, plug it in, solve for one variable, plug that variable back into the second equation, and find my second variable. We know how to solve systems by using elimination, where we're going to add both of the equations together, and the goal is to eliminate one of the variables, solve for the leftover variable, plug that value back into either of the equations, and find the second variable. And then we learn how to deal with and graph linear inequalities. We talked about the shading. We talked about the importance of that and being neat. Very similar to graphing a regular equation. Remember, if it's less than or greater than, it's a dashed line. If it's less than or equal to or greater than or equal to, it's a solid line. And then today we're going to put it all together and we're going to solve systems of linear inequalities, okay? So we're going to have at least 2, maybe 3, 4, 5, who knows? Depends how complicated the system is. We can have at least 2 or more inequalities on the same graph. Now, in order to solve systems of linear inequalities, simply graph and shade each inequality individually. That's where people mess up. They try to graph everything together all at one time and they want to shade at the end. That, in my opinion, will lead to mistakes. Go ahead and graph and shade each inequality individually, one at a time, my friends. And then the area of the system which has an overlapping solution. Those are the solutions of the system of inequalities. So luckily, there's nothing really new to teach here. It's just being able to put both skills together on one graph. So let's get right to it. Okay, what is the solution of the following systems of inequalities? Okay, for A, what do you think we should do here? Yes, sir. Okay. For this particular case, you could solve for y, or if you realize, hey, wait a second, this is in standard form and I can find the x and y intercepts very easily, you can do that as well. So what's the x-intercept for this first guy? Okay, 4, 0. What's the y-intercept? 0, 4. Okay. What's the slope here? What is it? Down 4 over 4, right? So what's the slope? Guys, what's the slope? Down 4 over 4. So what's the slope? -1, right? So remember, you got to have a few more points. So down 1 over 1, down 1 over 1, up 1 over 1. Up 1 over 1. Boom. Now, I messed up there. Should that have been a dashed or a solid line? Dashed. Am I going to shade above or below? Read from the y. Y is greater than, so above. Remember, be neat. Trust me, you're going to see y now in a second. Now, what's my x-intercept for this bad boy? 7, 0. 1, 2, 3, 4, 5, 6, 7. What's my y-intercept? 0, 3. 1, 2, 3. Okay. This one's going to be dash or solid? Solid. Am I going to shade above or below? Okay. What is the part that overlaps? What is the part here that overlaps? Isn't it this area right here? Everything in here? That or those are my solutions. And that's as easy as it gets. Yes, sir. No, you don't have to individually identify the separate points. Just point to the shaded area. Okay? Now, I want to show you something that I like to do, but I wanted to show you the answer first before I did it. You know that you're looking for the overlapping area, right? You already graphed and shaded your first red line. Now you're graphing and shading your second blue line. I could shade this area, but is it worth anything to shade that area? Why? Because it's not intersecting with anything, correct? So once you have the first one shaded, look to see where it's going to overlap. Where it's going to overlap is between here, correct? Do you see that, my friends? So to make your graph easier, you could just shade the area that you know is going to be overlapped. Now, if you want to do it all, you're saying to yourself, Mr. Morrow, look, I just like doing it like this, and then later I can tell, hey, this is my solution set. That's fine. God bless you. That's awesome. But to make your life easier, you don't have to shade the non-solution part. Does that make sense? Okay, thank you, my friends. Thank you very much. All right, over here. Okay, I got y is less than 2x minus 3. My y-intercept is negative 3. My slope is up 1, 2 over 1, up 1, 2 over 1. Go backwards, down 1, 2 over 1. And is it going to be a dash or solid line? Dashed. Am I going to shade above or below? It's less than, so it's below. Nice and neat. Please. Now, I'm going to solve for y here. I'm going to subtract 2 to both sides, 2x. So I got y is greater than negative 2x plus 2. What's my y-intercept? What's my y-intercept? 2. What's my slope? Down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. Let's go backwards. Up 1, 2 over 1. Dashed or solid line? Dashed. Am I going to shade above or below? Above, because it's greater than, so it's right here. See where I have a little checkerboard now? All of this region, forever, those are my solutions, because there are an infinite many solutions. There are infinite many solutions. Does that make sense? Do you see now why I do my vertical lines instead of scribbly shadings? It makes it a lot easier to detect where you cross, correct? Wherever you have that checkerboard, that's where your answer is. So even if you don't do it in different colors, which, by the way, it helps. If you want to get yourself a blue pen or a blue pencil and a red pencil and a regular pencil, that helps a lot. But as long as you're neat, it doesn't really matter. Does that make sense, gentlemen? Okay. May I continue? Yes, you have a question. Yes, sir. When you take the test, will I allow you to use pens just for the shading part? Yes. May I continue, my friends? Thank you, gentlemen. Okay, number 2. Okay. What do I got to do here first? Solve for y. Thank you. So I'm going to subtract 2x to both sides. So I've got negative y is greater than or equal to negative 2x minus 3. How do I solve for y? Divide by negative 1. Very good. Y is now less than or equal to 2x plus 3. You guys with me? Okay, what's our y-intercept? 1, 2, 3. Good job. What's my slope? 2 over 1, up 1, 2 over 1, up 1, 2 over 1. Let's go backwards. Down 1, 2 over 1, down 1, 2 over 1. Dashed or solid? Solid line. Above or below? Guys, y is less than or equal to 2x plus 3. Above or below? Below, because it's less than. You understand that, my friends? So if you don't understand that, it's going to be hard to do the rest of it. Okay, what's my y-intercept for this bad boy? 1. What's my slope, gentlemen? Down 1 over 1, 2. Down 1 over 1, 2. Down 1 over 1, 2. Let's reverse it. Go backwards. Up 1 over 1, 2. Up 1 over 1, 2. Dash or solid? Dash or solid? Solid. Am I going to shade above or below? Y is greater than, so I'm shading above. Bam. See how nice the checkerboards come out? All of that area. Those are your solutions. I put an S because there's infinite amount of solutions. This makes sense, my friends. This is not that bad, right? As long as you know how to graph. Now, if you don't know how to graph, then it's just really, oh my goodness, what are we doing here? But I know that you guys know how to graph. I believe in you. I have confidence. May I continue, or do we have any questions, problems, or struggles? Okay, may I continue? Thank you. All right, next. Okay, this one I made it easy for you. They're already in y equals formats. So let's check it out. Y is less than negative 1/2 x plus 3. What's the y-intercept here? 3. Perfect. Thank you. What's my slope? Negative 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2, up 1 over 2, up 1 over 2. Dash or solid? Solid. Well, that's ugly. That's an ugly line. Okay, solid. Very good. Above or below do I shade? Below because it's less than. Excellent. Now, 2. I'm going to do it in the same color just so you can see it pops out the same way. Okay? What's my y-intercept now? No, my y-intercept, my brother. That's okay. Thank you. Negative 2. Now, my slope, though, you said it. That's right, up 1 over 1. Thank you very much. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Is it going to be dash or solid? Solid. I'm going to shade above or below? Above. So, do you guys see how even with the same color you see the checkered part? That's it. So this whole area right here, forever, all of this, those are my solutions. Please don't forget, it's not a solution, one, it's infinite amount of solutions. And if you wanted to test it, of course, take any point here, plug it in, and it has to work for both equations. Has to work for both equations. Does that make sense? May we continue? Okay, your favorite part. Word problems. Your city's cultural center is sponsoring a concert to raise at least $30,000 for the city's youth services. Tickets are $20 for the balcony seats and $30 for the orchestra seats. If the center has 500 orchestra seats, how many of each type of seat must they sell? Okay, let's analyze this, okay? First of all, we have orchestra seats, which, okay, I'll call X as well. Why not? And then we have balcony, which we could call Y. Is everyone with me so far? How much money do they want to raise? At least $30,000. So, $20 for every balcony seat, plus $30 for every orchestra seat. Go ahead, has to be at least. What does at least mean? Thank you very much, son. Greater than or equal to 30,000. Phenomenal. Does everyone understand that first equation? Now, here's what you got to think. If the center has 500 orchestra seats, how many of each type of seat must they sell? If the center has 500 orchestra seats, how many of each seat must they sell? And you know what I should have done? I should have put here, has at most. Let's add that in there, because if not, that's going to mess things up. So if the center has at most 500 orchestra seats. How could I write that as an equation? Talk to me. Nope. Nope. The center has at most 500 orchestra seats. No, let's think about it. Who is orchestra seats? X or Y? Okay, so no. No. The center has at most 500 orchestra seats. So orchestra seats are less than or equal to 500. Talk to me there, guys. This confused you guys. Why? Yes, sir.
I thought you would plug in 500 to the X.
No, if I plug in the 500 to this X, that means that I for sure sold 500 of them. That's not what they said. They said if the center has at most 500 orchestra seats, that means that orchestra seats must be less than or equal to 500, no? Does that make sense?
Yeah.
Okay, so now, you have your two equations. Now let's graph it. Check it out, guys. For this, huge numbers like this, what did I always suggest? Getting your x-intercept and your y-intercept. What's the x-intercept? When y is 0, what is x? Huh? Guys, when y is 0, what is x? 1,000. Very good. And then y-intercept. When x is 0, what's 0, 1,500. So, let's go here by intervals of on the x, let's go by intervals of 10. No, of 100 rather. No? Yeah, of 100. So this is 1,000 over here. On the y, let's go by intervals of 150. So this is 1,500 over here. Okay? It's going to be a solid line because, right? Now, greater than or equal to. So am I going to shade above or below? Above. Now, my orchestra seats, I have less than or equal to 500. So I go 100, 200, 300, 400, 500. 500 is going to be a solid line right here. And am I going to be less than or greater than that? To the left. Very good. So, what are my possible solutions? This little piece right here. Anything in here will be a solution. Talk to me, my friends. Talk to me. Yes, sir. Thank you.
Just curious, why didn't you go by intervals of 500? Could you have done that?
You could have gone by intervals of 500 if you wanted to, but I like to show the graph a little bit bigger. That would have been a really tiny graph. Questions on this, my friends? Yes, sir. This is 500 because I'm going by intervals of 100. Yes, sir. Thank you, sir. Any other questions on this concept? All right, let's do another one. A pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each type of topping can you get on your pizza? Yes. Yes, sir. What do you want to call X, brother? Okay, so veggie is X, they say, and we're going to say Y is our meat. Very good. Great start. Now, what do I know? Okay, each vegetable topping is $1 and each meat is 2, okay?
So 1, can I come wrong?
Of course, please.
1x plus 2y has to be less than or equal to 10.
Fantastic. You have $10 to spend. So that means $1 for every veggie topping plus $2 for every meat topping has to be less than or equal to $10. Fantastic, son. Fantastic. What else do you know?
Like one at least five.
There you go. There you go. There you go. Nice. You want at least 5 toppings. So you want from the veggies and the meat at least 5. So that's no. So that's at least is greater than or equal to 5. Bam. Let's graph, my brothers. This blue graph. Whoa. This guy right here. Let's put this guy to the side. Let's solve for y. Gonna subtract that. Go ahead. Wait. Actually, yes, you can. Thank you very much. Good job. You can do the x and y intercepts instead for these. Absolutely. For the blue one, what's my x-intercept? When y is 0, x is 10. What's my y-intercept? 0, comma 5. Very good. So 5, 10, solid line. Am I going to shade above or below? Less than. Y is less than. So below. Very, 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 very good. Now we'll do this sucker in red. I can also do the x and y intercepts here, can't I? What's my x-intercept here? 5, comma 0. What's my y-intercept here? 0, comma 5. Phenomenal. So it's here, and then 1, 2, 3, 4, 5 here. Above or below? No, y is greater than, guys. So above. So what is it? This little piece right in here that I'm going to color in green. All of this. All of that. That inside that little green triangle, those are my possible solutions. So for example, I can get 1, 2, 3, 4, 5, 6. I can get 6 meat and 1 veggie. 6 veggie and 1 meat, because we said x was veggie. For example, we could do that. We could do 1, 2, 3, 1, 2, 3. I can do 3 and 3. 3 and 3 works. Oh, actually, no. Yeah, yes, it does. 3 plus 3 is 6. 6 is greater than or equal to 5. And 3 plus 6 is 7. 7 is less than or equal to 10. Yes, it does. As long as it's inside that shaded region, you test it always, but it's going to work. Does that make sense? Folks? Yes? Okay. Last one, okay? Let's see if we set this up the right way. So, may I continue, my friends? All right. Now, you're planning what to do after work. I messed this up on your paper, so you may have to scratch out some parts. Sorry. You're planning what to do after work. You can spend at most 6 hours kayaking and paying bills. You want to spend less than 2 hours paying bills. What is a graph showing possible ways to spend your time? What are my 2 variables here? Okay, who do you want to call what? X we'll call kayaking. And then Y is paying bills. Boo. But you got to do it. Okay, what are my 2 equations here? Says you can spend at most 6 hours kayaking and paying bills. So that means that if you take some time to kayak, plus the time to take bills, pay bills, that has to be at most 6. So you got it. It has to be at most, so that's less than or equal to 6 hours. Because you got to go home and go to your family, all that good stuff. But then what's my second equation? You want to spend less than 2 hours paying bills.
So y has to be less than 2 hours.
Has to be less than 2 hours. Very good, son. Very good. Awesome. I'm so proud of you. Okay. Let's do it, my friends. What's my x and y intercepts here for this guy?
6, 0, 6006.
6006. Thank you. You are on fire, son. 3, 4, 5, 6. Shaded or dashed line?
Shaded.
I mean, dashed or solid. Sorry. Sorry. Shade above or below? Below. Now, I know that I can only pay bills. I only want to pay bills for less than 2 hours. So what kind of a line is a y equals line? Okay, well, you're telling me all crazy things. First of all, you're telling me undefined. Undefined is not a line. Undefined is a type of slope that belongs to a vertical line, but that's wrong. So what kind of an equation is a y equals? Is it a horizontal line or a vertical line? It is a horizontal line. So I go here to my 2, and I go forever this way. But I want it to be less than 2 hours. So actually, what I do wrong there should have been a dashed line. Do I shade above or below? I want to spend less than 2 hours. So I'm going to shade below. And anything in this little trapezoid figure here in blue, anything there is a possibility. So for example, let's say I want this right here. That's 1, 2, 3. So I can kayak for 3 hours and pay hours for a bill.
We do 412.
Yeah, you could do 4-1 as well. You could do 5-1 as well. Okay? You could just kayak for 6 hours pure. Does that make sense? Any questions on this? All right, my friends, thank you so much. I hope you learned a lot. Have a great day.